When we look at the ambiguous case, when two sides and a non-included angle are given, we may have two possible solutions. This is known as ambiguous case. Therefore, we need to examine the given information carefully when using sine rule. Okay, so this also raises another concern when using the sine rule, and this is that if we are given a triangle where two sides are given, let's say side is triangle A, B, C, and we're given, let's say, 72 degrees, and we're given two sides where in which one side is opposite the given angle. So let's say this one is 9.7 centimeters, and side angle A given is 7.5 centimeters. So once we are given, of course, this fulfills the sine rule as it is, because we have a side and a side opposite to a given angle, and then a side opposite a non-given angle. So this fulfills the sine rule. But anytime triangle of this sort is given to us where two sides and a non-included angle are given, so two sides which one an included angle is given, but our concern is that this side does not have an included angle. So two sides and a non-included angle, this side A is given. We may have two possible solutions. This is known as ambiguous case. And why is it so? It is so because ambiguous case is involved when the side opposite the non-included angle is less than the other given side as seen in the diagram below. So in this diagram, let me take it again. Ambiguous case is involved when the side opposite the non-included angle is less than the other given side as seen in the diagram below. So this is a note, but generally, when two sides and a non-included angle are given, we may have two possible solutions. So whether or not, even though, okay, let me be clear here so that you not be confused. This here is a general, this is what the ambiguous case means generally. Then this note, these are ways after once we have any triangle of this sort, two sides and a non-included angle, we just have to have it at the back of our mind that there may be two solutions. Then the final answer will now boil down to checking if indeed the solutions need to be two, and that is if any of these conditions is being met. So let's take this as an example. So in the diagram for this first note, so assuming we solve this triangle with this general overview in mind, that since we have two sides and a non-included angle, there may be two possible solutions. Then once we have gotten our answer, we're going to use these rules to check if indeed the solutions are ambiguous. So if ambiguous case is involved when the side opposite the non-included angle is less than the other given side as seen in the diagram below. This is diagram. So when the side opposite the non-included angle, the side opposite the non-included angle, which is this side, is less than the other given side. So this side A is less than this side B. But always take note of the side that doesn't have included angle if it's less than the side opposite to the included angle. So in the diagram above, which is the same diagram, A, which is this side, is less than B. So, and that also means that angle A is less than angle B. So this will give us an ambiguous, this is an ambiguous case rather. Then for B, no ambiguity. So the only time that the solutions will not be two or two, the only time that we may not have two possible solutions is if the side opposite the non-included angle is greater than this given side. So if the side opposite the non-included angle, if this, let's now have P, Q, R, so this is the included angle 72 degrees and this is 8.7 centimeters. So if the side opposite, what this implies that the only time that there will be no ambiguity is if the side opposite the non-included angle. So then let's take this side, this is non-included angle, and the side, if the side opposite the non-equated angle is greater. So let's say it's 10.87 centimeters. So this is a non-equated angle. We have two sides and an equated angle. So this fulfills sine rule. But if the side opposite the non-equated angle is greater than the side opposite the equated angle, then there is no ambiguity. Okay. So this particular triangle has only one solution. So there's no ambiguity. And then the next condition for a non-ambiguity case is that the given angle is obtuse, since we cannot have two obtuse angles in a triangle. So if the given angle is obtuse, in this case, let's say one of the angles is okay, let's go this way. Again, it's a B, where B is 117 degrees, and B. So we have A, and then we have C, and then we have the side. This is 7.1 centimeters, and then we have the non-equated angle to be 4.2 centimeters. So even though the side facing the non-equated angle is less than the side facing the equated angle, but as long as the given angle here is obtuse, greater than 90 degrees, this is a case of non-ambiguity. That's what this condition implies. So the given angle is obtuse, since we cannot have two obtuse angles in a triangle. So generally, always try to determine if the triangle you are solving is one that falls under ambiguous case. And how do you know? You would know if only two sides are given. So first of all, check how many sides are given. Two sides and an included angle. Then check if the side opposite the non-included angle is less than the side opposite the given or included angle, then that may involve an ambiguous case. So once you have solved that triangle, you will not need to use this to test whether it's a case of ambiguity. If the side that is opposite the non-equated angle is less than the side opposite the included angle or the given angle, then it's a case of ambiguity. Then when you solve, and you will know what the solutions are. So the examples that I'm going to give from here, we're going to see how to apply these rules. In triangle ABC, so let's draw triangle ABC. In triangle ABC, A is 32 degrees, A degrees, B, and side A is 8 centimeters, and B is 12 centimeters. So what do you notice? You notice that two sides and an included angle are given, of which one of the sides that is given is opposite the included angle, and the other side that is given is not opposite. And the other side that is given is opposite a non-included angle, which is this part B. So since this is the case, then there might be this might be a case of this might be an ambiguous case. So that's our general hypothesis now. It could be it could involve an ambiguous case, but we are not sure if it is. We are going to solve, and then once we are done, we are going to use our this to test whether it is true. So now let's see solution. We're told to look for find angle B and C. So angle B and C will give us, and since the ratio, since it's fulfills sine rule, so we're going to using sine rule. So we're going to say sine A, the angle on the side that's known, which is sine A over A, is equal to angle, the side and the angle that's not known, sine B over 12. So, okay, sine B over B is the formula. So sine A is 32 over sine 8 is equal to sine B over 12. And this will give us 8. So sine B is equal to 12 sine 32 degrees over 8. This will give us 0.7949. 0.7949. So B, remember this is sine. B equals 0.7949. So B is equal to arc sine 0.7949. So press shift in your calculator. You can get arc sine 0.7949. 52.6 degrees. That's the answer. So since from what is stated here for the ambiguous case, when two sides and a non-included angle are given, we may have two possible solutions. So since this is a case of two sides and a non-included angle, let's see. So 52.6 is 52.6 degrees is equal to, sorry, B is equal to 52.6 degrees, and this is an acute angle. So this means that B is in the first quadrant. So there's a possibility that B is also in the second quadrant. So since sine is positive, in first and second quadrants, first and second quadrant, it implies that B can also be. So in the second quadrant, this is the value for sine in the first quadrant, which is acute. The second quadrant, sine is obtuse, which means it's less than 180 degrees. So you subtract this angle from 180 to 2.6 degrees. So B is equal to 180 minus 52.6, 127.4. 127.4 degrees. So this is also another possible answer for B. So let's get the value for C also. So we're going to get the value for angle C from angle sum property. Why? Because already we've known angle B, which is 52.6 degrees or 127.4 degrees. So now we have two angles. So to get the third angle, we simply have to use the angle sum property to get angle C. So C is equal to 180 degrees minus 32, which is angle A, plus the acute angle B. B as acute angle plus 52.6 degrees. So the C is equal to 180 degrees minus. C is equal to 180 degrees minus 32. 84.6 degrees. So 180 minus 95.4 degrees. Now this answer for C is so to get the other equivalent, of C. So already you can see that the value of C is more than 90 degrees, and for acute angles are less than, theta is less than 90 degrees. So once theta is greater than 90 degrees, that's obtuse. So this is the equivalent, the value or the equivalent of the obtuse angle, the equivalent of C. So let's get the other angle or the other possible angle, which would in turn be an acute angle. So or you can say C is equal to 180 degrees minus 32 degrees plus this angle 127.4 degrees. 180 degrees minus 59.4 degrees, which will give us 20.6 degrees. So this angle is less than 90 degrees. So for C, this second option is the acute angle equivalent of C, while the first one is the obtuse angle equivalent of C, or the obtuse angle of C. This is the acute angle of C. Therefore, E is equal to, angle B, which is what we're told to look for. B is equal to 52.6 degrees, 52.6 degrees, or 127.4 degrees, and C is equal to 95.4 degrees, or 20.6 degrees. So this is the case of ambiguity, and we did this because of this condition where two sides are given. And so once two sides are given, and the other side, the second side, which is the second side is opposite a non-included angle, then it might involve a case that could be ambiguous. And this implies that we're going to have two possible triangles for that from the solution of B and C that we have gotten. Our first possible triangle is the first one. The first option is 32 degrees. Is 32 degrees. Remember, is 32 degrees, and then B is 52.6 degrees, and C is obtuse 95.4 degrees. So it's slightly above the 90 degrees range. So at least one of them is obtuse, so that implies ambiguity. Also, this is the first form of solution. Then the second triangle, since the second triangle B is 127.4 degrees, so we're going to be mindful of how we draw the triangle. So we're going to look something like this. Okay, so this is the obtuse angle because it's greater than 90 degrees. 127.4 degrees, so this must be B, and then the others are acute. So A is 32 degrees, this is A, 32 degrees, and then this is C, 20.6 degrees. So these are the two possible triangles. So anytime two sides and a non-included angle is given, you must be careful with the way we go about the solutions. We are going to check if it satisfies the condition for ambiguity. If it does, then we provide two solutions. But if it doesn't satisfy the condition for ambiguity, then we also state it. And that condition is no ambiguity if one, the side opposite the non-included angle is greater than the other given side, and two, the given angle is obtuse. In triangle PQR, PQR, PQR 78.5 degrees, 78.5 degrees, PQR, PQ is 14.8 centimeters, and PR is 18.2 centimeters. Find angles R and P. Let's look for angle I and P. So the triangle that's given to us, two sides and a non-included angle. So this side has an included angle, but this side does not have an included angle. So this will give us an ambiguous case. But then the final test of whether this triangle is really one that involves an ambiguous case is after we've gotten our solution, we're going to run the test. to see if it's indeed an ambiguous case. But generally, this is an ambiguous case because two sides are given and a known angle is given. So let's solve. Since it fulfills the sine rule, we're going to using sine rule. And then you have sine q over q is equal to sine r over r. Sine q is 78.5 degrees over q, which is 18.2, and that will equal to sine r over 14.8. So sine r equals to 14.8 sine 78.5 degrees over 18.2. Sine r is equal to 14.8 sine 78.5 divided by 18.2, 0.7969. 0.7969. So r is equal to r sine 0.7969, and r is equal to 52.8 degrees. 52.8 degrees. So this r is equal to 52.8 degrees. And this is the acute angle since it's less than 90 degrees. So we'll come here to since sine is positive in the first and second quadrant. Yeah, it implies that r can also be r is equal to 180 degrees minus the acute angle 52.8 degrees. 80 minus 52.8, 127.2 degrees is the obtuse. Therefore, two possible solutions for r are 52.8 degrees and 107.2 degrees. Now the two possible solutions for question says we should look for angles r and p. So we've got the value for r. So now let's look for p. First, possible solutions for p. So using the angle sum property, using the angle sum property equal to, so p equal to, so let's use the acute angle first. Okay. 180 degrees minus, in our triangle, so if q was given to us 78.5 degrees plus the acute angle of r 52.8 degrees. 52.8 degrees. Which is 180 degrees minus 131.3. 48.7 degrees, or p is equal to 180 degrees minus 78.5 degrees plus this obtuse angle 127.2 degrees is equal to 180 degrees minus so we are 5.5 degrees. So when we subtract, you're going to have minus 25.5 degrees. So, but you know that an angle cannot be negative. This implies that that is 180 degrees minus 78.5 degrees plus 127.2 degrees is greater than 180 degrees, which is not supposed to be. So since two angles cannot be greater than 180 degrees in a triangle, it implies that P cannot be 127.2 degrees. 127.2 degrees. And so therefore triangle PQR has only one solution, so no ambiguous case is involved. No ambiguous case is involved. So why are we coming to this conclusion? Because from what we have here already, if you try to get the obtuse angle of P, we discover that it's not possible, and that's because triangle R has an obtuse angle. So since we cannot get it by trying to get the obtuse angle of P, and so it implies that since P does not have obtuse angle as R has obtuse angle, it shows that this triangle with these angles and side given is not one that involves ambiguous case. Now this one fulfills the condition too. The given angle is obtuse since we cannot have two obtuse angles in a triangle. The first example we did, we had two answers for each of the angles we found, but in this case we couldn't get two options for P as much as we could get for R. That's because since R is obtuse in this case, P cannot be obtuse, unlike the first example we did. So that's why I said for the general rule, once you have two sides and an included angle, especially when one of the sides has a non-included angle, just have it at the back of your mind that your solutions may be two, so you have to find two solutions for your answer. Then when you are looking for the two solutions, when you get to a point where you couldn't get the obtuse angle of one of the angles you are looking for, then you know that that particular triangle does not have two solutions, so it is not really ambiguous, even though it fulfills the condition of two angles and a non-included angle, which is a case of ambiguity. So this is the way you run the test. That was why I couldn't explain this way in the first example, but at least with this you can see why this what this part means. So when we run the check, when we try to cut the obtuse angle of P, we discover that it will be greater than 180 degrees, but in a triangle only one angle should be greater than 180 degrees, because after all the sum of angles would be equal to 180 degrees. So if two angles are equal to 180 degrees, that means it's no longer a triangle, it's something else, and that has violated the triangle property. So in a nutshell, our angle is the solution of this angle. So we're going to say therefore, I'm going to come here. So therefore the R is equal to 52.8 degrees and P is equal to 48.7 degrees. So if you observe, I did not include the obtuse angle of R, which is equal to 127.2 degrees, because P does not have obtuse angle, unlike the first example I treated where both of them have obtuse angles. So we have to draw two separate triangles using the angles that we got, both the acute and the obtuse. But in this case, since P does not have obtuse angle, because two obtuse angles cannot be in a triangle, that means that the solution set is only one. So R is equal to 52.8 degrees and P is equal to 48.7 degrees. Find the remaining angles of triangle ABC, in which A is 12.5 cm, C 70.7 cm, and C was 116 degrees. This is angle C, 116 degrees, 17.7 cm, and E, B. The E is 12.5 cm, and then C, this is B. So this is a case that involves ambiguity, but we can't tell. But then let's solve so that our solution will tell us if it's really a case involving ambiguity or something else, or not rather. So since it fulfills sine rule, let me say using sine rule, then we'll use sine E over A is equal to sine C over C. Sine E is what we are looking for, and side E is 12.5, sine C is sine 116 degrees over 17.7 centimeters. So sine E is equal to 12.5 sine 116 degrees over sine over 17.7. So sine E is equal to 12.5 sine 116 divided by 17.7, 0.6347, 0.6347. So E is equal to arc sine 0.6347. Angle E is equal to 39.4 degrees. 39.4 degrees. So you can say, since this is the acute, so since two sides and a non-included angle is given, or two sides and an included angle is given, where the other side doesn't have an included angle, we have in the back of our mind that this is a case that involves ambiguity. So let's get the outer angle, which is possibly the obtuse angle. So that here, since A is also equal to, A is equal to 180 degrees, and so say or in this case A is also equal to 180 degrees minus 39.4 degrees. That will give us 180, or let me do it here. So from here we see or A is equal to 180 degrees minus 39.4 degrees. This will give us 180 minus 39.4, 40.6 degrees. Now, so this is obtuse and this is obtuse. So what does this rule say? The given angle is obtuse. Since we cannot have two obtuse angles in a triangle, so no ambiguity. If true, the given angle is obtuse. So the given angle already is obtuse, so we cannot have another obtuse angle in the same triangle. So since C is the given angle, since C the given angle is obtuse, A cannot be obtuse. A cannot be obtuse. Why is it so? Because of this rule, we cannot have two obtuse angles in a triangle. So A is equal to 39.4 degrees only. That's the value of A. So from here, to get the other angle, because question says we should find the remaining angles of a triangle ABC, of which only angle C was given. So we've gotten angle A using sine rule. Now we can use angle property. Using angle sum property, B is equal to 8 degrees minus 39.4 degrees plus 116 degrees plus 180 degrees minus 39.4 plus 106, 155.4 plus 5.4 degrees. 24.6 degrees. So therefore angle A is equal to 39.4 degrees, 9.4 degrees, and B is equal to 24.6 degrees. In triangle ABC, E is 7.1 cm and B is 9.5 cm and B is 63 degrees 18 minutes. So this stroke on top of 18 minutes. So let's get B is 63 degrees 18 minutes, and then A, C, B. So B is 9.5 centimeters, and then okay, so that's all that. Okay, A is 7.1 centimeters. So this fulfills the use of sine rule, and also since we have a given side and a non-included angle, we have to, that means it could be a case of ambiguity. So let's start using sine rule. Right now we start to solve the triangle completely. So that means to solve the triangle completely means that you should find all the unknown angles or the non-included angles and also the unknown side. So we're going to look for these two angles and this side C. Okay, so using sine rule, we're going to start off with this and this. So using sine rule, sine B, which is the sine A, sine B, sine A over A is equal to sine B over B. Sine A is unknown over A, which is 7.1, equal to sine B, which is 63. Now we have 63 degrees 18 minutes. So what we need to do is to convert minutes to degrees. 60 minutes equal to 1 degree. So 18 minutes equal to x degrees. So x equal to, when we cross multiply, 60x equal to 18, and x equal to 18 over 60. And then 2 here, you have 6 into 18 is 3, 6 into 6 is 10. So 3 over 10 is 0.3. At 0.3, x equal to 0.3 degrees. 0.3 degrees plus 63 degrees plus 60 degrees, we're going to have 63.3 degrees. So our degrees is 63.3 degrees, 0 degrees over B, which is equal to 9.5. So sine A is equal to 7.1 sine 63.2 degrees over 9.5 sine A is equal to 7.1 sine 63.3 6.3430 divided by 9.5 0.6677 0.6677. So E is equal to arc sine 0.6677. E is equal to 41.9 degrees. Now, since we already know that this could be a case of ambiguity, we could decide to get the value. This is acute. We could decide to get the other value for A. So let's say E or E is equal to 180 degrees minus 41.9 degrees. So 180 minus 41.9, that's equal to 138.1 degrees. Now this is where this rule applies. Now we can leave the answer like this, but strictly, let's see. So I left this part here because I was going to refer to what I have here. So I want to use this part now. I've referred to this part and I've referred to this part. Now I want to refer to this part. So here it says in the diagram above, A is less than B, so angle A is less than B. So here in this diagram, the angle we got, angle E is 41.9 degrees, while angle B is 60.3 degrees. So definitely angle A is less than B. So if angle A is less than B and the angle given to us B here is not obtuse, it's acute. So we cannot get two options in this case. So since A is less than B, which also implies that angle A is less than angle B. So this implies that A is equal to 41.9 degrees. Why? Because B is not obtuse. B is 63.3 degrees, and 63.2 degrees is greater than 41.9 degrees, the acute angle. So we cannot get the obtuse angle of A for this reason. So our answer will be limited or restricted to the acute angle only. So which in this case shows that we cannot get two possible angles for this. So if A is equal to 41.9 degrees, using angle property, we can get C using the angle sum property. Angle C is equal to 180 degrees minus 180 degrees minus 180 degrees minus 63.3 degrees 3.3 degrees plus 41.9 degrees 180 degrees minus 105.2 degrees. .8 degrees. So C is equal to 74.8 degrees. Now we're trying to solve the triangle completely. So we've gotten angle E, we've gotten angle B, angle C, and we know angle B from angle B was given to us. So the side that we have not known is C. So let's get C. So get C, so we're going to use the sine rule. So using sine rule. So now that we've known Now that we've known both angle A and angle C, so we're going to use any of them. So because angle A, we've known angle A, and angle C, the side A is given to us, and angle B is known, the side is given to us. So we can use any of the known angle on the side as a ratio and equate it to C, for which we are going to look for the side C. So either we use angle B to this and the side, or angle A and the side. So let's use B and the side. Sine B over B is equal to sine C over C. We could also use sine A over A equal to sine C over C. So sine B is given as 63.3 degrees, and B is 9.5. Then sine C is what we got here, sine 74.8 degrees over C. So C is equal to 9.5 sine 74.8 degrees over sine 63.3 degrees. So C is equal to 9.5 sine 74.8 divided by sine 63.3, 10.2, 10.26 centimeters, which is equal to approximately 10.3 centimeters to 1 dp. Finally, answers correct to 1 decimal place are. So answers correct to 1 decimal place are angle E is equal to 41.9 degrees. 41.9 degrees. Angle C is equal to 74.8 degrees. And then C is equal to 10.3 centimeters. Then answers correct to the nearest limit. Answers correct to the nearest limit, or E. So now what initially the answer was given to us in minutes. What the angle given to us rather was minute was part of it, 63 degrees, 18 minutes. So let's convert these angles to be in this form where we have both the angle, so both in degrees and in minutes. So now what do? We're going to do the reverse. So 60 minutes is equal to 1 degrees. So what do? 60 minutes equal to 1 degree. And now, so this part here, 41.9 is split into two parts. 41.9 degrees is equal to 41 degrees plus 0.9 degrees. So we want to convert this part to minutes. So 0.9 degree. So x minutes equal to 0.9 degrees. So we'll cross multiply. X will give us 0.9 times 60 degrees. That will give us 0.9 times 60. That's 54. So that will give us 41 degrees, 54 minutes. So C is equal to 74 degrees. 74 degrees. So of course here will be 0.8. So 0.8 times 60, that's 48. 74 degrees, 48 minutes. And then C is equal to 10.3 centimeters. So that's our answer.